Good morning everyone, this is BremSter, and today I'm coming to you with a puzzle called Arrowmathics by Sotek. Yeah, I'm probably just going to jump into the puzzle. I will say all of the normal YouTube stuff, so please like the video if you like the puzzle or the video or both or whatever. Subscribe to the channel if you're not subscribed. I am getting more and more viewers who are not subscribed to the channel, so it's always good to see that. Apart from that, all of the needless preamble is just me trying to get the watch time up, and while YouTube loves watch time, and do I, it's really profitable, I think you're here for the puzzle, and I respect my audience too much to do needless preamble. Needful preamble I will do, but at the moment I've got nothing to say. So, puzzle. So, what do we have on Arrowmathics by Sotek? Normal Sudoku rules apply. So, in every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. And then add arrow. Digits on an arrow must sum to the digit placed in that arrow circle. So these three cells, the sum of those gets placed there. These two cells, the sum of those gets placed there. Now, digits may repeat on an arrow if allowed by other rules. So it may be possible for both of those to be 1 and that to be a 2. That might be fine. Now, the other thing, it's not mentioned in the rules, but the different color arrow here, this is just to make sure that it's very, very clear that this is one arrow, and there's no like hiccup happening here. The original one where they were all grey, there was a question from a tester. It's like, hang on, does this arrow do this? And like, what's going on? Should be very, very clear now about this is one arrow, this is a different arrow, this is a different arrow. The others don't overlap. So just to make sure that the overlapping arrows are clear. That's it. I'm going to restart the puzzle to restart my timer. Let's give this a shot. Of course, links below to this puzzle. You can see how much I care about the timer. Links below to this puzzle and a whole bunch of other links as well, which you can look through if you want. Sotek's been a long-time supporter of the channel, so all the ways of supporting me are below. As well as joining the community and finding lots of other puzzles and all sorts of stuff. So this is interesting, isn't it? I mean, low-hanging fruit. The minimum that this could be, it'd be 1 plus 2 plus 3, because I can't repeat any of those digits that are in the same box. So this has to be at least 6, but it can't be any higher than 9, because it's a single digit. But this is what is interesting me, because this cell is the sum of those two cells. This cell is the sum of those two cells. So this cell is the sum of those 4 cells. Now, the minimum that 4 cells could be would normally be 1, 2, 3, 4. But that's not quite, which would make that 10, which doesn't work. But that doesn't quite happen here, because this cell could repeat in one of these 3, which means that, yeah, the minimum these could be would be 1, 2, 3, which is 6. And then this could be a 1, 2, or 3. And the 6 plus this 1, 2, or 3 means this could be 7, 8, or 9. And this is the same. These have a minimum of 1, 2, 3, plus that, which could be 1, 2, or 3, means these six, 7, 8, or 9, this is 7, 8, or 9. Right, now. But it means that the maximum this could be is 8. So it has a 1 here and a 1 here. So there is no 1 here. Now, only one of these can be a 9. If I put a 3 here, this becomes a 9. This becomes less than a 9. And I couldn't put a 2 here. No, I could. 2, 1, 2, 3, 8, 3, 1, 2, 3, 9 would put 1, 2, 3 here. No, that doesn't. No, that. Ooh, row 5 is interesting, isn't it? Because if I put 1, 2, and 3 here, then what I've got left for these is 4, 5, 6, and 7. No. Yeah. Yeah, 4, 5, 6, and 7. But 7 and 4, which are the minimums, sum to 11, and there's no 11 here. Sorry, 5 and 4, which would go for the 9, but then I've got a 6 and a 7 left over to cover the 7, and that just is completely nonsense. So I can't put 1, 2, 3 in both of those. In fact, can I even repeat a 2 in one of those? if I made this 1, 2, 3, could I put a 2 down here? Because it'd put 1 and 2 in here. So if this was 1, 2, 3, and this was, say, 1, 2, 4, 1 and 2 would be in here. Then I could do 3, 4 on one side, but that would leave 5, 6, so that's not going to work. 3, 5, 4, 6 doesn't work. 3, 6, 4, 5 doesn't work. I can't put 1 and 2 in here because the minimum these could be would be 3, 4, 5, 6. 3, 4, 5, and 6. How would I make these have any combination? Because 3, 4, 5, and 6 is 18, and these would both need to be 9. 3, 4, 5, 6 is 7 plus 11, which is 18. That does not work. I can't put 1 and 2 in here. So I can't have 1 and 2 in both of those. One of them could have a 2, but not both. Because then I'd have to put 2 in here, and I don't have 2 here. I need to have 2 in one of those. It's the same true for 3. Like if I have 2, 4, 5, 6... 2, 4, 5, 6 is only 17, which means this could be 8, 9. But how do you make 8? But one of these must be less than 8. So one of these must have a 2. One of these must be less than 8. So which means it must have a 1, 2, because if I don't use a 2, 1, 3, 4 is 8. But one of them must be less than 8, because it must be less than 8, so I can add something to it to keep this under 8. So one of these must have a 2 on it, which means the other one doesn't. Can I ever put a 3 here? If I put a 3 here with 1, 2, 3... this becomes 9. And that doesn't work now. Oh, that's cool. If this was a 3, this would have to be 1, 2, 3, 9. Now what can I put here? Because I couldn't put a 3 here because I need 1, 2, 3, 9. That doesn't work. But I could never put a 2 here because then I'd put 1 and 2 here and this row would be broken. So I could never put 1 and 2 here. So if I go 3, 1, 2, 3... what do I put down here? The minimum, because I couldn't put a 2 here, would be 1, 3, 4 with 1, and this would also have to be 9. And the logic is symmetrical. You can never put 3 in any of those. That is really cool. Oh, wait a minute. Let's add those cells to the mix. This is that plus that times 2. And this is in the same box as that is. So the minimum this could be is 16. Because the minimum these could be is 1, 2, 3, 4, 5 plus 1. So if this was a 7, how would I make all of those cells sum to 14? There's no way of doing it. 1, 2, 3, 4, 5 is 15 plus 1 is 16. So there's no way this could be a 7. And the same is true here. If I add these cells to this mix, the minimum these could be is 1, 2, 3, 4, 5 plus 1 is 16. This can't be a 7. This is 8 and 9. Okay, another thing I just realized, which I could have done immediately. I think I can go further with this now. But this can't be 1, 2, 3 anymore, or 1, 2, 4. It would break that. 1, 2, 3, nothing here. 1, 2, 4, nothing here. So this isn't 6 or 7. As soon as I got 1, 2, 3, it couldn't have been 6. But once it's 1, 2, it can't be 7 either. And the other 1, 2 must be on here, because if I don't put a 1 or a 2 on here, this is 3, 4, 5. 3, 4, 5 is 12. That's not a 12. So this is an 8, 9 pair. But I think I can go further with this. What's the maximum digit I can put in here? Because this can't get higher than 18. Sorry. This can't get higher than 18. So this can't get higher than 17. So I can't put anything higher than a 7 on here. But if this was an 8, I couldn't use 1, 7. Could I use 2, 6? I could, you know. 1, 1, 2, 4. No. No, I can't use 2, 6. If this was, whichever one is 8, can't be 2, 6. Because while I could make a 2 here by doing 1, 1, how do I do the 6? Oh, 1, 5. No, it can't be 1, 5. I've gone 1, 1. It can't be 2, 4 because I've put the 2 here. This can't be 2, 6. So the 8, wherever the 8 goes, has to be 3, 5. So I'm putting that in as a note. It could be here. So the 9 can't be 1, 8, could be 2, 7, can't be 3, 6, can't be 4, 5. So these are 2, 7 and 3, 5. So these are 1, 4, 6. Now, 2, 7 and 3, 5. Now the 8 is going with 3, 5. So where the 8 is, the 8 has got 3, 5. So this would have to be, so where the 8 is would have to be 1, 2. No, that doesn't work. Oh, no, but I can repeat. Hang on. How do I make 8 in those? I'd have to make 7 in those. No, I have to, wherever the 8 is, I have to make 7 in those with 1, 2, 4. And this would have to be a 1. I can't make 6, 1, 2, 3, because right. So where the 8 is, you've got 1, 2, 4 with 1. Where the 9 is, it's 2, 7. So it's 1, 3, 4. Both of these are 1. Because where the 8 is, it's 2, 7. 1, 3, it has to be 1, 3, 4. And both of those, which is 8, so both of those are 1. So there's no 1 in either of those. So, I don't know which one is which. How do I figure out which one is which? Well, I can't put the 2 in there because I can't make that 1, 1. And the 2 went with the 7, so I can't put the 7 in there. So, one of these is 1, 1 in that position. And it's 2, 7. And the 7 then couldn't be 1, 6. It couldn't be 2, 5. So it would have to be 3, 4. So one of these is 1, 3, 4. The other one, that was for the 2, 7, 9. The 3, 5, 8. Well, let's just do this one as the 2, 7, 9. Let's do this one. Oops. It's the wrong thing I wanted to move. Let's do this one as the 358. So I'm removing, this is, again, I'm just, if this was the 358, if this was the 3, this is the 2. If this is the 5, this is a 4. If this is the 3, this is 1, 2. If this is the 5, it's either 1, 4, well, it couldn't be 2, 3. It'd have to be 1, 4. So you'd end up with that. So 1 is always in. So this is 2, 3, 4. This is 2, 3, 4. This is 1, 3, 4. 1, 3, 4. And this is 1, 2, 4. 1, 2, 4. With 1 having to be in those. And this could be 2 and this could be 7. I'm not sure how this is helping me. I mean, that's true. Oh, this, right, the 1. It's this arrow. As soon as I put the 1 there, this is 2, 3, 4, absolute minimum, making this the 9, making this the 8. The 8 was the 3, 5. So this is the 3, 5. This is the 7, 2, 1, 1. This has to be the 7, which is the 3, 4. This 8, this 8, the 3, 5. Let's redo this. And I'll keep the yellow. Although I think I can get rid of the yellow now. But let's finish this off first. It was this arrow. If this is the 3, that's the 2 or 4. If this is 3, this is 1, 2. And if it's 5, it's 1, 4. So this is never the 1. This is the 1. And that is this. Done. Great. That's really, really clever. That was kind of tricky, though. This is the 9. So I know what these 3 digits are. 5, 6, and 8. So I know what these 3 digits are. 3, 7, 9. Well, I'm not putting 9 partway along an arrow that sums to less than 9. I know what these 3 digits are. 6, 7, and 9. Again, this isn't a 9 for multiple reasons. So this can be a maximum of 3. So this is 2 or 3 only, because if this was higher than 3, the minimum would be 6 and 4, and this would have to be 10. But the minimum this could be, this has to be an 8 or a 9 with 6, 2. It could be 6, 3, 9 or 7, 2, 9 as well. These are 2, 5, no. Yeah, 2, 5, 8. Okay. There's no 1 on this arrow. Or maybe it's this arrow I should be looking at. I am now feeling a little stumped as to where to look. I seem to have incredibly minimal arrows for resolving this. These are 5, 6, 7, and 8, but I can't see what to do with that yet. I can't put a 1 on this, and I can't put 2, 3 on this. This is a minimum of 6 with 2, 4. So this is 6, 7, 8, 9. Minimum here is 5. Well, 1 is in one of those two. There's no 1 on this either. 1 is in one of those two. There's no 1 on this. So all of these arrows don't have 1 on them. Is it this arrow, though? Yeah, this can't be a 7. If this was a 7, this can't be a 1. So it'd have to be 7 to 9, and it can't be. This is a 3, so there's no 3 in any of those. So this is either 2, 3, or 5. But I don't see a problem with any of that. I mean, this break-in was nasty. Nasty. There's a lot going on in box 7. Can I figure any of that out by maths? Like these digits here sum to those digits there. So those digits there, these could repeat though. And I can't put a 1 in any of those. So the minimum of those is 2, 4, 5, 6. Oh, that's so cool. Because I can't put a 1 in any of them. Because 1 is down here. And I can't use 2 and 3. So the minimum would be 2 with 3 here, and then 4, 5, 6. 2, 4, 5, 6 is 17. So if I put a 6 in one of these, the other one has to be 11. There's no 6 in there. 7, the other one would have to be a 10. This is a 9, and this is an 8 or a 9. That is amazing. That's an 8-9 pair now. There's no 8 there. The 8-9 makes that the 7 and that the 9. That's amazing. But these are under a lot of pressure because of this. I can't use but 2 of 2, 3, 4 in there. In fact, there's another high digit that is forced in as well, because 2, 3, 4, 5, I'm already using 3 of them. So let's look at this 9. It can't be 1, 8. If it was 2, 7, I'm not sure about the order on that one. 2, 7, 3, 6, 4, 5. I don't know, you know. But what's the maximum digit I could put on this? So the minimum I could do is 2, 4, 5, 6, which is 17. I could increase one of those digits by 1. It could be 3, 4, 5, 6, or it could be 2, 4, 5, 7. 4 and 5 must be in here. It's either 2, 4, 5, 6, 3, 4, 5, 6, with that being a 2, or 2, 4, 5, 7. Can I see how to narrow that down? The 9, this is a 1-9 pair now though. But I can't make both of those 4 and 5. This can't be the 4, 5, because then this would be 2, this would be 3, and I'd already have 4, 5, 6 in the column. 7 in this, well, that means this is 7, 8, doesn't it? This is 2, 3, 4, 5, 6. So this, right, 2, 3, 4, 5, 6. No, I could put, no, I can't put 7. Oh, no, I could put 7 in here because I can make, this is 2, 3, 4, 5, 6, 7. I just put minimums in here. I can increase the 6 to a 7 or the 2 to a 3. But I can't put a 9 on here. I can't put an 8, but I can't put an 8 on this. So the 8 is down here. This is the 9. This is the 8, which means this is 6, 2. There is no 2 on this. So now the minimum on this is 3, 4, 5, 6, which is 18. This is 3, 4, 5, 6. That is cool. And this is 7, 8. The 8 is looking down, making that the 7 and that the 8, which is putting 8 in one of those two. That's amazing, isn't it? One of these is 3, 6, the other one is 4, 5. There's no 6 there, so there's no 3 there. The 2 is looking up saying there's no 2 there. This is 3, 4, 5 by the column, but 3 and 4 is on the line. That's the 5. There's no 5 there, so there's no 4 there. There's got to be something else going on in these columns, because this is just too nice. This triple, 1, 2, 3, 4, 5, 6, 7, and 8. Well, there's no 8 there. That is 6, 7, 8. So there's no 6 there, so there's no 3 there. Oh, this is so... I feel like I'm pair hunting. Four, 5, or 3, 6. You know, I feel there's something here. And I can't quite see it. 9 is in one of those two. 9 is in one of those two. Oh, hang on. This 9 makes this the 1 and this the 9, which means that's not the 9, that's the 9, which puts 9 up here, but I can't put 9 on the arrow or anything. 9 is in there. 1 in this box is in one of those two. 7, no. Oh, this is another really cool trick, but I'm stumbling a little. This 6, of course, makes that the 7, which takes 7 out of those, which makes that the 7. I'm glad I removed the color, because I do find removing the color makes it easier to scan. I find when you're scanning, you have to, if there's stuff on color, you do one set of scanning for digits that aren't on color, one set of scanning for digits that are on color, and you just lose it. Getting rid of the color really does help. I mean, I'm still not great at scanning, but it helps. Does that do anything? The 6, 8? No. These are 2, 3, 4, 5. 5 is in one of those two. But if this is 5, this is 4. This is 3, this is 5, this is... Hang on, if this is... Whoa, whoa, whoa. If this is 5, this is 4. This is 3, this is 5, which makes that 4, and both of those are 4. That is not the 5, which means I've got a 2, 3, 4 triple. That's the 5, that's the 3, that's the 2, that's the 4, which makes that the 3, that the 4, that the 3... that the 6. The 3 makes that the 4. 4 comes out of those. The 3 looks up making that the 2 and that the 3. That was weird chain. And I think I lucked onto that. But I'll take it. I will take it. This can't be 8 or 9 now. So it's 5, 6, or 7, because the minimum it could be is 2 and 3. Whew. No, it can't be 2, 3. That can't be 2 or 3. The minimum that cell can be, it can't be 1, 2, 3, 4. Minimum that could be is 5. And that can't be a 1. So minimum that could be, it can't be 1, 2, 3, or 4. Minimum that could be is 5. The minimum that could be is 2. And the maximum that could be is 7. This is 7, 2, and 5. It takes 5 out of there. That puts 7 in one of those two. This is the only, well, these two arrows are the only ones I haven't resolved. So, hooray for Sudokuville. 3 is in one of those two. So what do we have? We have 3, 4, 6. Oh, that cell. Sees 1, 2, 3, 4, 5, 7, 8, 9. That's the 6. So it's 3, 4, and 8. So that's a 3, 4, 8 triple. There's no 8 there. So there's no 5 there. That's only a 2 or a 3. So with the 3, 4, 8, this is a quadruple. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 1, 2, 5, and 6. There is no 1 there because of that. Don't know that that does much for that arrow. There's no 6 here. It's a 6, 8 pair. That's 5. That's 2. There's no 2 here. This now has to be, well, hang on, minimum. Minimum here is 3. So this is 3 or 4. And this is 8 or 9. And it's not 9. This is 8, and these are absolute minimums, 5 and 3. The 3 looks down, making that the 4 and that the 3. That takes 3 out of here, making that the 3. There's no... Whoa, 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 whoa. How did that break? 1, 2, 5, 6. There's no 1 here. Let's do this again. Is this correct? No. Oh, no. I've made some hideous errors. So when I put that in, was it correct? Yes. So I just made some errors here. This is the 2. This is the 4. This is the 3. Which means this is the 4. This is the 5. Was there a better way of doing that chain that I did? But it was true. If this was 5... Oh, this... Hang on, I removed 5 from there. If this was 5, this was 4, this was 3, this was 5, and that was 4. It was a fairly obvious chain. The 2, 3 makes that 4. Which makes that 3, which makes that 4, which makes that 5, which makes that 3, which makes that 6. There's no 3 or 4 there. That's the 2. So that's the 4. Is this now correct? Right. Let's push on from here because I obviously made a terrible error. Okay. People yelling at the screen isn't what I'm here for, but it happens anyway because I am an updie. Okay. Now, let's look at this arrow again because the maximum here is still 7. Minimum here, 1, 2, it could be a 3. Because I got this the wrong way round. So what I did on this arrow was completely wrong. The maximum here is 7. This could be 3, can't be 4, 5, and it can't be 7. So this is 3 or 5. 1, 2, 3, 4, 5, 6. 3 or 6 because the maximum here is 7. 1, 2, 3, 4, 5, 6. But 3, maximum this could be is actually 4. So 2, 3, or 4. 5 would need to go with 2. 3 would need to go with 4. That can't be, well, no, that could be a 3 if this is a 6. If this was a 5, would work, but it can't be a 4. So this is 5 or 7 only. Yeah, okay. That feels... 7 is in one of those two, though, by Sudoku. Because I can't put 7 there, because that would have to be higher. 7 is in one of those two. 8 is not there. Or that's an 8, though, because of these two 8s. That's the 8. That is the 7. These sum to 7, so there's no 3 there. 8 does take 8 out of there, so this is either 3 or 2. This is a triple now. 1, 2, 3, 4, 6, 7. There's no 7 there. These are 1, 2, 3, and 5. So 3 is in one of those two. So 3 is in one... Oh, 3 is in one of those two. That's the 2. That's the 5. And there's no 5 there. That might be a better way of doing the puzzle. Why is it a better way? Because it's correct. Now, the minimum on this now is 3, 4. So this is a 7 or an 8. It must contain a 3. There must be a 3 on this arrow. Because if there's no 3 on this arrow, the minimum would be 4, 5. It would have to be 9, and that doesn't work. So this is 3, 4 or 3, 5. There's no 5 here. If this was 3, 4, that would be a deadly pattern. So I don't think it's going to be that. But I'm not going to assume anything at this point because I've made mistakes before. Oh, no, 7, 7. 7 is in one of those two. Ooh. Two is in one of those. 3 is a bit more. Well, hang on. 3 must be on the arrow. So 3 is in one of those two. Because I can't put 3 in any of those or any of those. 3 is down here. Is this really this tricky? 4 is down here somewhere. I mean, I've already made errors on this puzzle, but is this really this tricky? 7 is not in any of those, but 7 is in one of those 3. These are the only 2 arrows I haven't resolved. So this cell can't be 1, could be 2, can't be 3, 4, could be 5, can't be 6, 7, 8, 9. 2 or 5. What's this quadruple? 1, 2, 3, 5. 6, 7. 1, 2, 3, 5. There's no 1 there. There's no 3 there. This is 2 or 5. That doesn't feel like it, does it? Well, hang on a minute. It does a bit, because now this is 2, 3, 4, 5. So 2 is down here, because 2, 3, 4, 5 only go in those cells. So these are 6, 8, 9. But that's not really helping much. Or if it is, I'm not seeing it. I get the feeling there is something really powerful going. There's no 2 here. 2 is in one of those 2. Oh, but there's no 2 in either of those. That's the 2. This is a 5, 8. Because 2 looking down and the 2 here looking up. That's a 2. 5, 8. So up here, there must be a 3 up here. And it can't be... So this is a 3. So the quadruple here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there must be a 5 in here. There's no 1 here. This is 4, 5, 6. Six is down here, but that's not news. I really don't want to use that deadly pattern. Like, I know that has to be a 5, otherwise this puzzle... Oh no, this could resolve the deadly pattern. So it's not a deadly pattern. These could be 3... Oh no, it couldn't. If this was 3, 4, and this was 3, 4, if this was a 7, this puzzle would have 2 solutions. But I don't want to use that. There's got to be something else I can use. 1, 2, 3, 4, 6. So these are 1, 2, and 6 in this column. Because 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 1, 2, and 6. But I can't put 2 here. And I can't put 1 here. That's the 6. That is not the 6. I can't put 2 here because in this column, the 2 needs to be down here because of the 2, 3, 4, 5 quadruple. So this is a 1, 2. And the 2 makes that the 1 and that the 2. There's no 1 here. This is a 4, 5, 6. That's the 1. There's no 1 here. None of that's really touching anything, is it? So this is now 2, 3, 4, 5. So it's 3, 4, 5. 2, 5 or 4, 3. Oh, this can't be 2, 5 anymore because of that. This is 4 and 3. That's really... It was that cell preventing that from being 2, 5. So this can't be 3 or 4. That's the 5. That's the 2. That is really cool. That's the 3. That's the 4. This is not the 3. That's the 3. The 4 is looking up, making that the 5, and that's the 8. Knew it had to work out. I just didn't know how it was going to. That was cool. The 8 makes that the 5 and that the 8. The 5 makes that the 2. This is not the 2. The 3 takes 3 out of both of those. That's 1, 5. So that's the 3. This is the 1, 5. The 5 makes that the 1 and that the 5, which puts 1 right there. The 5 takes 5 out of there. So this is 4, 6, or 8. So it's not the 7. Wait. No. Don't pencil mark incorrectly. The 8 makes that the 6, which makes that the 8, which makes that the 4, which makes that the 5, and makes that the 7. That's better. Pencil marking incorrectly is what got me into this mess in the first place. 6, 7, and 9. This isn't a 9 because I've got a 9 in the column already and I've got a 7 in the row. That's the 6. There's no 7 and there's no 6. This is the 9. This is the 7. The 6 and the 9 make that the 8, which makes that the 6 and that the 8. This isn't a 6 or an 8. That is a 9. These are 4 and 6, and I'll use the 6 to make that the 4 and that the 6. The 6 to make that the 4 and that the 6. Now, there's a 6 and a 7 in this column, so that's the 4, making that the 6 and that the 7, and that is the correct solution. Okay, I made some mess-ups, but boy, were there some tricky spots in there. I loved this. And I was doing some deductions in these 3 cells and how they would bounce back before I realized, hang on, it's this plus this times 2 is that. And then this stuff here with these, and this being a 2, 3, and there not being a 1 on there, forcing these to be high, was really cool. This chain here, I'm pretty comfortable that that was I don't know if it was needed, but I'm pretty comfortable that that was spottable, because this being a 5 made that a 5, which made both of those 4. That's not a hard chain to see, because these arrows were overlapping each other. That I'm very, very comfortable with that. I did mess up in the middle, and with all the double 3 stuff, I might do another edit point in the video to try and point out that, yes, I see the mistake and I will fix it. I will get to fixing it. Thank you everyone for watching. I hope you enjoyed Arrowmathics as much as I did. Sotek's puzzles are always fun. Yeah, thanks everyone. Again, I don't feel like wasting too much of your time, so I'll just sign off. Good luck with your solving.